Alright, hello. I'll make another devlog. I enjoy making these devlogs really. I'm struggling at the moment to actually stream. There's something about the flow state and how it's really distracting. I really can't manage to sort of concentrate when I stream. But I thought I'd make a little bit of an update through video instead. It's sort of cathartic and sort of put my mind in the right place, simply to just go over what I did and how I did it, and sort of reflect on the work I've done and the progress and everything. That's really nice. So yeah, anyway, I'm gonna make a video today about cutscenes and cinematics in Godot, which is obviously a thing that isn't naturally implemented in Godot. Well, I suppose there's the animation player, but it's really not up to task with a lot of things that I'm asking it to do. So, but I think you could make cinematics with the animation player. I mean, I have in the past actually. I have in the past in Grand Fantasy Heroes. I've done that. So, but for this particular project, I needed to come up with a novel solution. Okay. So the first thing I'm going to do is maybe just show you the cinematics I've made so far. So this is the first one. It's sort of like a jumping cinematic. When you go to the next system in the chain or whatever, you press this button, and then you press a location or something, and it plays this cinematic. They sort of jump into a don't worry about the glow at the moment. I know the glow is sort of broken. And yeah, you go into this. This is actually a loading screen right here. So we're just loading up the next level. And this is a shader I found on Godot shaders, which is excellent. Of course, I made some modifications to it and all of this, but really nice that it was there. And yeah, so you go to the next level, and I made like a little. This is the next cinematic I made. Just it's probably not going to use anything like this. I'm just testing stuff out. Yeah, so they follow a path, and they come around this cube. I move the camera around and stuff like that, and then yeah, we go into battle. It all works and things, and we're now fighting. I know the glow is broken. Please don't touch that. Okay. Yeah, that'll be fine. Okay. So yeah, there's the cinematic. So how did I go about doing this? So we have, it took a lot of refactoring. The first thing I sort of had to refactor was the way ships spawn into the scene. The simplification really than the way I was doing it before. Previously I had sort of a wave system where ships would spawn in according to their wave. I would create like several waves of ships, and this could either be I have the old code down here actually somewhere. Be like create waves. Yeah, you have sort of we could have a max amount of ships in a wave, or we could have random sort of sized waves, but really this was inappropriate for what I actually want to do. This is good way to do it for maybe a custom battle or a random battle or something like that. But for when I want to do a cutscene, I want to do like scenarios, I want to do missions, and I want to create these missions. You know, I want to create interesting adventures for you to go on, and stories and all of that. That's more my priority for this upcoming demo, is to do that sort of story-based missions rather than just random missions. So that's really what I want to lean towards, and I can always add in the custom and random battles later on. Anyway, so yeah, I switched the way I'm doing the spawning in. So now, let's see, we simply have, there's mainly just 3 different sort of functions here. We spawn in a ship, and this will just spawn in a ship, give it some rudimentary keys and data and stuff like that. We initialize the ship. This is actually giving the, well, I've had a better description of what I wrote it down. Okay, separating out ships into spawned, initialized, and activated. Spawned, they exist, but they have no data, and they could be hidden. So they're hidden from the player. They're turned off. So this is essentially your object pool. So I can keep them hidden and deactivated, and then when I need them, I bring them into the scene. But they will normally be initialized as well. So they just have they have some data, and that's all ready to go. But there's no AI. So activated, the AI is in control and they're fighting. And so at the initialized stage, so the non-activated stage, that's when the cinematic control happens. So you can see in this first example, we went from AI is working. See, this AI is working. And it's flying around and all of this. I can switch ship, and the AI is working and everything. And then we went from that sort of state to a unactivated state. So I have no control over the ship. I can't move. Anything like that. Bam. And this is probably also an example of a unactivated state here when we're in this cinematic. And then we go into this one, and this one starts unactivated and then becomes activated. So, and then let's talk about, that's like sort of new sort of, I'm calling them states. They're not really states. They're just booleans. I don't know. I guess they're states in a weird way. And then let's talk about the cinematic controller, which I'm kind of proud of. The solution. I got the idea from the animation player. So the animation player, I can add an animation player. I was thinking about how this might work under the hood. And I was thinking about this. It's got this dictionary, right? Right? And this is your animation. It's the dictionary. And what is this doing? Maybe it has a set of instructions that it's doing, and it's following those instructions, and it's sort of lerping between those instructions on a process. So that's what I ended up doing, was I create a dictionary called cinematic body instruction data. And then we add to that various instructions. So I can tell it to, so we add the camera pivot in this example. We add the instruction to move lerp to node. So we're lerping the camera pivot to the bus player body, the player body. We've got a speed, we've got a threshold, is indefinite. So either I want it to stop its instruction once it arrives at the arrival threshold, or I don't. And then we have look at vector, and I wanted to separate these out to make them very obvious what's going on. So we have look at vector, but we also have look at node. So I'll show you the instructions down here. Process look at node. but we also have process lookup vector, and then we have move body in the direction of nodes. This is your, I want you to move as it, I want to position plus you, but use a direction to give that sort of natural looking movement that a ship should have. Because, you know, there's a very with the animation player, there's a very jerky sort of behavior a lot of the times. So this is combating that, but also the lerping is combating that sort of jerky behavior. And yeah, you can move either, and I know you probably could like combine these two instructions, right? You're moving the body in the direction of a vector, or you're moving the body in the direction of a node. But I wanted to like simplify it, make it obvious, so I don't have to guess what I'm doing. We're lerping to a vector, we're lerping to a node, we're lerping local. So I'm moving my local position, that way I can move my camera relative to the the pivot with this sort of lerp. And then we have the advanced path follow, but that's not actually really what I was using in the end. I'm more using the process attached path follow move away. It's a mouthful, but what this does is I have a path follow, right? Let's delete that. I have a path follow. These are my paths here. And these path follows sort of start over here, obviously, and then they progress. And all I did was sort of attach this path follow to an instruction and give it the instruction to move away from this this ship here. So whenever this ship would get too close, it would progress. And there's also a looping boolean in there, so I can potentially loop it as well. So I can make patrols and things. And yeah, so that is pretty much it. I'm pretty happy with this. I'm sure, and I can just keep on adding more instructions to the instruction data potentially as I need them. So yeah, that is pretty much it. That's all. I think that's all I wanted to show today, and thank you for watching.